All right. I'll go and get started. I realize I started late and then screwed up the link. It's my fault. But how this is going to work is I will go over every question. I'll just go through this. I'll show the work that I would expect. And then as you guys have questions, just ask. Just ask in chat. All right. I don't think this will take a huge amount of time, but I'm willing to spend as much time as I need to. All right. Couple of quick things. Things we've gone over. Oh, and my mouse doesn't go that far. All right. Hold on a second. Oh. Well, whatever. All right. So some things that we've gone over that I'm going to expect you to know on this test. All right, so the first is lines. And we've gone over a whole bunch of different lines. We've gone over y minus y1. Is equal to m times x minus x1 for the given point x1, y1. Right, so that's just basically 1 point. Slope of the line, that's the difference in y's over the difference in x's. Y equals mx plus b. Same thing, b is the y-intercept. So it's 0, comma, whatever your y-intercept is. We've done composition of functions. We've done f of g of x. We've used this with parent functions. And that is, hold on a second. Then we did circles. We did a little bit of factoring at the very start. So we did circles, r squared is equal to x minus h squared plus y minus k. Can't write that far. I don't know why that's happening. All right, give me 1 second. I need to fix this. There we go. Okay. Am I posting this when I'm done with the review? Yeah, this just automatically posts. All right, so it might take a little bit, but it'll be here. All right. So for a circle of radius r and center hk, right, we get the equation above. Right, the radius squared is equal to x minus h squared plus y minus k squared. I think that just about covers it. A little bit of factoring and inverses. Inverses I will explain a little bit more once we get there. Okay, but I want to just start with this stuff so I don't keep screwing things up. Yeah, I'll just start with number 1, right? So slope, the first thing you do when you're given 2 points and you're trying to find the equation of a line, right? Make sure to read the directions, is to find the slope. So the difference in y's, -5 minus -2, over difference in x's, so -3 minus -1 is equal to -5 plus 2, it's -3. -3 plus 1, it's -2. So our slope is 3/2. Okay, easy, worth a point. Again, if you are questioning like how I'm going to give points or whatever, go to On Campus. The rubric is posted there. It's in that review Algebra 1, Algebra 2 topic. Okay, so that's the slope. And then all we got to do is label 1 point x1, y1 and then we're pretty much done, right? We just stick it into this equation, and that's it, right? So we get y plus 2 is equal to 3 halves x plus 1, right? And there are different answers, right? You could plug the other points in. You could do it in slope-intercept form. So really, there are 3 different answers I would take. This one, plugging in the other point, or solving for slope-intercept, right? Write an equation of the line through the given point with the given slope. This is the same thing as number 1, just one less step. So we're given m, and that's really all we need, right? So we have m, and we have a point x1, y1. So I would just plug this in. Y plus 2 is equal to negative 1/3 x plus 3. Okay. If you wanted to do this like the old school way, using slope-intercept, you would use that point, right? So negative 2 would equal negative 1/3 times negative 3 plus b. And then you'd have to solve for b, right? So then negative 2 would equal 1 plus b. So negative 3 is equal to b. And then you get y is equal to negative 1/3 x minus 3. Okay, so this would do. I don't really care which way you do it. I think the point slope form, this one, is a whole lot easier. But if you're really comfortable with doing this over here, that's fine too. Okay. And then the last line problem is number 3. So write an equation of the line for the given graph. All right. This is easy. This is just y equals mx plus b. The same thing you've been being taught since freshman year, okay, or maybe even before. The first thing you do is you find your b. The b is the y-intercept. That's this point right here, and that's negative 1. Then you find your slope. So the slope is the rise over the run. So that is, right, from this point we go up 1, then we go over 3. So it's equal to 1/3. So then our equation, just plug those 2 things in. So y is equal to negative, just positive 1/3 x minus 1. I'm hoping we don't have a whole lot of questions on 1 through 3. Again, these are just graphing lines. So I'll just scroll through these real quick. And then we'll go on to the next ones. Okay. 4 and 5, we didn't practice factoring a whole lot, but it seemed like people understood it from when I went over it. We spent maybe like half an hour, 40 minutes on it. All right. Number 4 is the one you guys know how to do, which is surprising. Not surprising that you know how to do it, but that we struggle on this one. But 4 is easy. Okay, we're just looking for factors of 28 that add up to 11. And some people need a factor tree or a factor table. I'll just make one just in case. So factors of 28 that add up to 11. So you could do 1 in 28, but that adds up to 29, so that's not right. Okay, you could do 2 in 14, but that adds up to 16, which is not 11. You could do 7 and 4. That does add up to 11. So these are the ones we're worried about. Okay, so our factors then are x plus 7 times x plus 4. Right, so if you were to FOIL this back out, right, x squared plus 4x plus 7x, that's 11, and then plus 28. That's what we want, right? So that's the first part. That's like half the problem. In fact, that's the hard part of the problem. Now what we need to do is we need to solve for x, or in this case b. I don't know why I wrote x, but we'll just roll with it. So if we have a factor of 2 things, if we have 2 factors multiplied together and it's equal to 0, then both have to equal, both could be 0, right? So either a is equal to 0 or b is equal to 0. In this case, a is x plus 7, and b is x plus 4. And then you just solve. So x is equal to -7 or x is equal to -4. That, in my opinion, is the harder factoring problem. Okay, but it seemed like people didn't understand number 5 as well as they understood number 4. All right, so for number 4, there's just two terms. So all you have to do is ask yourself what's in common between those two terms. All right, so 4n squared plus 5n. It's the thing you just constantly repeat saying, right? So there's an n involved. So if we factor out an n, what's left is 4n and then plus 5. All right, if we were to distribute this back out, we'd get 4n squared plus 5n, and we know that that's equal to 0. And then you're down to an easier case than the one on the left, right? So either this is equal to 0 or this is equal to 0. So n equals 0 or 4n plus 5 is equal to 0. And then you just solve. So this is an answer. And then n is equal to -5/4. All right, I want to pause there for like 20 seconds just to make sure people don't have questions, and then I'll go on to the inverses. All right, so the inverses, in my opinion, these are the harder ones of the test. All right, there still shouldn't be that difficult, but who knows? Okay, so really, if we know how to solve multi-step equations, these shouldn't be too terribly hard. All right, so what I like to do is I like to write this as y is equal to x minus 2 squared, or 2 cubed, minus 1. And then in order to find the inverse, all we do is we swap the x and the y value. So instead of y is equal to yada, 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 now x is equal to the same thing. When we do that, all we're doing is we're inverting all the applications, all the operations, okay? So then you just solve for y. So you add a 1 over to both sides. And now in order to get y by itself, we have to get rid of this cube. In order to undo a cube, we have to take the cube root of both sides. So what that looks like is this on the left, so the cube root of x plus 1. And then when you cube root a cube, you're just left with y minus 2. Okay, then you add the 2 over, and you're done. Making sure that that plus 2 is on the outside. All right, we're just going to leave this. All right. Same thing for the next one. Keep in mind, I could use any parent function here, and all you have to do is be able to invert them. All right. Does that show up good? Yeah, that shows up good. All right. So again, same thing. All we have to do is we swap the variables and then solve for y. So in order to undo a cube root, what we have to do is cube things. So we get x cubed is equal to y plus 3 over 2. We have to multiply the 2 out first. So we get 2x cubed is equal to y plus 3. And then subtract out the 3. And this is our answer. Okay, so again, I want to make sure people understand this. Swap the variables, solve for y. That's really all you're doing. Okay, so I'll give people another 15, 20 seconds to look at this, and then I will go on to the next one. All right. Okay, so just to make sure, read the directions. Okay, when it says find the inverse, you swap the variables and solve for y. When it says state if the given functions are inverses, that means we need to verify if these two are inverses of one another. When we are doing that, we have to compose the two. Okay, and you can do either g of f of x or f of g of x. I usually always do this, just because that's the thing most people see. So we do that, right? And our goal, if they are inverses, this thing should equal x. That's what we're checking for. So we need to check if that's true. Right, so then we can just compose the two. I feel like I should do the opposite. All right. Yeah, I'm gonna do g of f of x, because that'll end up a little bit nicer. All right, so when we do this, and I'll explain why here in a second, but when we do this, we get that g of f of x is going to be equal to the fifth root of x minus 3 to the fifth. Right, that's our input, and then plus 3. Now, the fifth root and to the fifth power, those things cancel, and we're just left with x minus 3 plus 3. That just equals x. Okay, so then that means that for now, these two are inverses. Okay, we could check f of g of x. The reason I don't want to do that is because if you do that, then you have the fifth root of x and then plus 3 to the fifth power inside, which, like, it's not as simple, right? Because we'd have to FOIL 5 different times, and we don't want to do that, right? So that's why I just chose g of f of x. All right. 9 and 10. Okay. Use the information provided to write the standard form equation of the circle. All right. So equation of a circle, that's the radius squared is equal to x minus h squared plus y minus k squared, where the center is hk. So all we do is we plug in, right? It gives you a center. Okay, that says that this is h, this is k, that's r. So all we do is plug in. So 2 squared is equal to x and then plus 3 squared plus y plus 15 squared. It's pluses because there's double negative, right? So it'd be x minus negative 3 and it'd be y minus negative 15. That's why those become pluses. There should be a square there. That's your answer. That's it. All it is plugging in numbers. Okay, number 10 is going to be a little bit different. So I'm going to give you a center and some other thing, right? In the other practice test, it was area of a circle. In this case, it's another point. Okay, 2 ways you could do it. The easy way is to realize that these two y values are the same. So all we're really worried about is the distance between 1 and -5. Okay, distance between 1 and -5, that's just the difference. That's just equal to 6. You could also do the whole distance formula, right? x2 minus x1 squared plus y2 minus y1 squared. You're going to get the same thing. Right, this will equal to 36. This will equal 0. And we still get 6. Okay, two different ways. That's, in my opinion, this is easier. Just realize that the y values are the same and then take the difference between them. Okay, this is the radius. If you take the distance between the center and any other point on the circle, that's going to give you the radius. All right, so now we just, again, plug into the equation and we're done. All right, so 6 squared is equal to x minus 1 squared plus y plus 13 squared. Okay, fair game things that I think you should know that this piece of information could be, right? In the other practice test, you found area. Area of a circle is always pi r squared. Could do circumference. I don't think I will do that, but that's 2 pi r. And then we could do another point. All those are fair game. Okay, point should be easy. That's like just what we did here. Area is easy. You've seen that before. Circumference, again, I don't think I'm going to do that, but in my opinion, you should know what circumference is. Okay, that's the first half of the test. Yeah, just move on to the next one. Right. Number 1, identify the parent function f of x and write an equation for the function given. All right, and I'm telling you that there are no dilations, so we don't need to worry about how wide or how narrow it is. You can just assume that, you know, it's as wide or narrow as it normally would be. And we just label what we know, right? So this is the parent function x cubed, and this is shifted down 1, right? So our function is just really simply x cubed and then minus 1. Number two, this is the parent function square root of x. It is shifted up 1. And it's the reverse direction. Okay, so it's switching from left to right to right to left. All right, so our equation is y is equal to the square root of negative x and then up 1 plus 1. Right, so this negative, that's the reverse direction. And then the plus 1 is the shifted up 1. That's the work I would expect you to do, right? Identify the parent. Tell me the shifts left or right or up and down. And then tell me if there's any reflections. And then give me the equation, right? So I think on that rubric, I said that that was worth 4 points. Each one of those is, the transformation is 2, but then the parent is 1, and then the actual equation is 1, I believe. Right. Number 3. Number 3 is a little bit different. It's the same type of question, but I'm telling you that there is a dilation. But on this one, there will be no reflection, right? So I'm just going to tell you that now. No reflection on this one. Okay. Same thing. You identify the parent function. That's absolute value of x. Okay. That is shifted left 3. And then from this, we can get a general equation. Right, so that would be y is equal to absolute value of x and then plus 3. Now, I'm telling you that there's a dilation. So there's going to be some something being multiplied here, right? And we need to take it a point and we need to test it. Right, so we're going to have some constant a that we're multiplying by. So if we pick a point, let's say negative 2, 3, we should be able to solve for a if we plug that in. Okay, so if we do that, we would plug in 3 is equal to a times negative 2 plus 3. Right, so 3 is equal to a times the absolute value of 1, which is just 1. Right, so then a is equal to 3. So now our function, if we plug it back in, is y is equal to 3, absolute value of x plus 3. That's the one that's going to require a little bit of thinking. But I'm telling you, you will set it up kind of like this, and then you just need to check a point. And then the last one, this is just function composition, so this is like an explicit version of this. Instead of just using, parent functions and shifts and shrinks, this is like literally just using function composition, right? So we're trying to find f of g of x, right? So we're trying to find f of x plus 9, and we just need to simplify as much as we can, right? So x plus 9 is our new input instead of just x. So we'd have 4 times x plus 9 squared minus 3 times x plus 9, and then plus 2. Just setting it up like that is worth something. Okay, same with this. So if we do this, we have to FOIL these x plus 9s. Then we distribute. X times x, that's x squared. X times 9 is 9x. 9 times x is another 9x. So that's plus 18x. And then plus 81. And then we just distribute again. And then combine like terms. And so long as I did all that right, that would be our answer. Okay, so that's all the problems on the test. That's exactly how I would do it. That's all the work I would show. I'll leave this up for a couple of seconds, but I'm going to leave it open to you guys. What questions do you have? Yes, again, this will be posted not immediately after. If you just kind of have this link, you'll be able to rewatch it. At some point, this is going to be just available, right? I'm not the one to post it. YouTube does that. It'll just be on my videos. Is that everything that's going to be on the test? Yes, again. This is exactly what you will see. All right, the numbers will be changed, but all the same types of questions. So I'm going to start from the top, and I'll just slowly scroll down. guess I can fix this. This means yes. This means yes, they are inverses. That is something I would expect you to have. Like, show all the work and then a yes or no. So both of these are a requirement, and that's on the rubric too. I think I state that. Right. That's the entire test. And again, how I would do all of it, I will leave this open for the next couple minutes, let's say 2 minutes. And if you have questions, I'll keep answering them. But if no one has any past that, I'll shut it down. All right. So, right, tentatively, I'll shut down at 7:50. But if you have questions, feel free to ask. Can you show the state if the functions are? I'm guessing you mean the question and or what it means to be inverses. All right. Inverses. That's number 8. Okay. If two functions are inverses of one another, right? So these two functions right here, f and g, those are inverses of one another if, when composed together, it simplifies down to just x. So in this problem, what we did is we took f as our inverse. We plugged it into x for g, and then we solve, or you simplify, right? So you have the fifth root of x minus 3 to the fifth. That cancels, so you're just left with x minus 3, and you have a plus 3 on the outside. Right, so then you have x minus 3 plus 3. That's just equal to x. So because that's equal to x, yes, they are inverses. Right, so inverses, if when composed together, they just equal x. If it doesn't just equal x, which you saw in the practice test, the other practice test that I gave you, then it's not an inverse. Um, if you're still on this link, if you need to watch it when you're done, I would just leave this link open just in case. But you can rewind, whatever. This will eventually be just up on my page, but I think it takes a little bit. Okay, for period 7 guys, it'll be no problem. It'll be up tomorrow night. For everyone else, it might take like an hour or so, but it should be up past that. So I'm gonna shut this down now. All right. If you have questions, please email me. I'm like always, I'm available tomorrow morning. Please let me know though if you're gonna come in, because I need to know like how to take care of printing and stuff. All right. So I'm gonna close this down. I will see you guys tomorrow or the next day. And again, like I said, this will be up in a little bit. All right. So thank you for watching, and I'll see you guys later.